Hello students, good morning. I am MANDEEP Singh Thakur, Assistant Professor in Electrical Engineering Department at Chandigarh Polytechnic College, Kurua. In this lecture, we will study about the transmission system of electrical power. Transmission system. Let us start with the PPT. Let me share a PPT with you. Here we go. Transmission of power. Transmission system. Electrical energy is generated at various power stations such as hydroelectric, thermal, or nuclear power stations. These power stations are located at far away from the load center or consumers. The electrical energy produced at the power stations has to be supplied to the different consumers. So, there is an extensive network of conductors between power stations and the consumers. This network of conductors can be divided into two parts: transmission and distribution system. The system by which bulk power is delivered to the load centers and large industrial consumers from power stations is called transmission system. Power system. The generation, transmission and distribution of electrical power is called power system. A power system includes generating of electrical power, transmission of electrical power, and distribution of electrical power. These three stages are covered in electrical power system. The electrical power is generated at hydroelectric, thermal, and nuclear power station by connecting number of alternators in parallel. The generated voltage at the generating station is generally 11 kV, which is stepped up to 132 kV, 220 kV, or 400 kV, depending upon the distance, the amount of power to be transmitted, and the system stability. It is then transmitted to the load centers with the help of conductors known as transmission lines. Finally, it is distributed to a number of small as well as bulk consumers. In it, we will study, let us start, transmission lines. These are the huge and bulky structure for transmission of electrical power. Introduction. Transmission of power. What is power transmission? Power transmission is the movement of energy from its place of generation to a location where it is applied to performing useful work. Electric power is normally generated at 11 to 33 kV. In a power station, to transmit over long distance, it is then stepped up to 400 kV, 220 kV, or 110 kV as necessary or as per requirement. Power is carried through a transmission network of high voltage lines. Usually, these lines run into hundreds of kilometers and deliver the power into a power grid. The grid is connected to load centers through a sub-transmission network of normally 33 kV lines. These lines terminate into 33 kV substation where the voltage is stepped down to 11 kV for power distribution to load points through a distribution network of lines at 11 kV and lower. Efficiency of transmission line. Whatever may be the category of transmission line, the main aim is to transmit power from one end to another. Like other electrical systems, the transmission network also will have some power loss and voltage drop during transmitting power from sending end to receiving end. So, performance of transmission line can be determined by its efficiency and voltage regulation. Every transmission line will have three basic electrical parameters. The conductors of the line will have electrical resistance, inductance, and capacitance. As the transmission line is a set of conductors being run from one place to another, supported by transmission towers, the parameters are distributed uniformly along the line. Here, the voltage regulation or efficiency of transmission line. The power sent from sending end minus line losses equal to power delivered at receiving end. Here is a mathematical representation. Efficiency of transmission line. We can say that the efficiency of transmission line equal to power delivered at receiving end divided by power sent from sending end into 100. Next, voltage regulation. The percentage regulation equal to no load receiving end voltage minus full load receiving end voltage divided by full load voltage into 100. It is the mathematical representation for voltage regulation percentage. Let us start. The transmission lines are categorized as these three types. The first are short transmission line, the second one is long transmission line, and the third one is short transmission line, second one is medium transmission line, and third one is long transmission line, as we see according to their length. First, short transmission line. The line length is up to 80 km. The range between 80 km the transmission line installed is called short transmission line. The second one is medium transmission line. The line length is between 80 km to 160 km. The third one is long transmission line. The line length is more than 160 km. Means these all are categorized according to their length of the conductor. The next is extra high voltage. Extra high voltage means 110 kV, 132 kV or 220 kV or 400 kV. Ultra high voltage means these are categorized according to voltage range. Ultra high voltage means 765 kV. The next is HVDC, high voltage direct current transmission, about 500 kV, plus minus 500 kV. Let us start the transmission line execution. Survey and profile plotting. Transmission line survey. A transmission line is one of essential infrastructures of the power supply system. In the site evaluation process for those facilities, it is necessary to carefully consider not only technical issues but also the impact on the natural environment, the influence on local communities and various regulations. To achieve optimum line length, minimize rocky and water drains, reduced tower angle cut points, raw issues, it is necessary to have detailed survey profile of transmission line routes. Why surveying is important? To optimize cost of transmission line length, number of locations and deviations. minimum river crossings, minimum forest areas, accessibility, right way of considerations, to assess route concentrates and do construction planning. These all come under the optimization of cost of transmission line. The second is to ensure statutory clearance, ground clearance. Second one is horizontal or right way clearance. And the last one is clearance from power lines, other power lines, railway lines, and road crossings. These are the some pictures which shows the ultra high voltage transmission lines of 765 kV requiring large row. These towers belong to the power grid through agriculture fields and through the hilly areas and over the road crossings. And here the multiple transmission lines through same corridors at the same area. Let us start the transmission line survey. Project conceptualization, project feasibility stage. Faster and accurate techniques required to evaluate various line routes. Pre-construction stage. Route alignment, detailed mapping of right of way, ground profiling, finalization of tower locations. And the second is come in this category, detailed countering of undulated terrain for estimation of benching and revetment quantities. The next one is project construction stage, check survey only in last day. Detailed survey, modern techniques, route alignment using latest satellite imageries superimposed of Survey of India topographical maps, digital terrains modeling in hills using countering data, detailed survey using GPS, total stations or ALTM, digitalization countering at undulated hilly tower locations, identification of route concentrates, identification of infrastructure details at that particular area, power spotting at optimization of locations using commercial software like PLS CAD, estimation of BOQ and preparation of survey reports, and the last one is soil investigation. Detailed survey, modern techniques, global GPS, global positioning system, and through total stations at that particular area, and PLS CAD, power line systems, CAD software. Let us start the detailed survey, modern techniques through GPS, global positioning system. The global positioning system is a space-based satellite navigation system that provides location and time information in all weather, anywhere on or near the earth, where there is an unobstructed line of sight GPS satellite. It is a modern technology that improves survey engineering to global orientation. Detailed survey modern techniques at total stations. A total station is a modern surveying instrument that integrates an electronic theodolite with an electronic distance meter. The theodolite uses a movable telescope to measure angles in both the horizontal and vertical planes. Coordinates of an unknown point relative to a known coordinate can be determined using the total stations. And the third one is PLS CAD, Power line systems, computer-aided design and drafting. PLS-CAD is the most powerful overhead power line design program. PLS-CAD is a sophisticated three-dimensional engineering model. The model can be viewed in a number of different ways: profile views, plan and profile sheets, 3D views. PLS-CAD supports both automatic and manual spotting. These are some pictures we share for PLS-CAD software. It shows us the sample routes profile through Google Earth. Sorry. Sample route profile in 3D images. And spotter tower through sample routes. And topographical maps digitized topo sheets and computerized route optimization by study of alternative routes at that particular area. We can see that the B line which we have to install existing line or alternative 1 and alternative 2 lines. And this is a computerized 3D image for all the lines, for B line, existing line or alternative 1 as well as alternative 2. Transmission line survey. The detailed survey is taken upon the line route approved by the concerned electricity board. Detailed survey should cover fixing of alignment, fixing of line points, fixing of angles of deviation, fixing of angle points, fixing of direction points, measuring of distance between angle points, levels at every 10-meter interval or where there is level difference of 30 centimeter. Here the difference is more, the survey took place. It also includes details of roads, details of villages covered through the transmission line installation, PNT lines, crossings, all power lines crossings, even LT to 765 kV lines, railway crossings, river crossings, agriculture wells, field bunds, and earth bunds. Measurement of soil resistivity at 1 kilometer interval. Trial pits, crop and tree enumerations. During the detailed survey, we have to avoid reserve forest area, military firing ranges, aerodromes, inhabited and thickly populated areas, hilly terrains, marshy, low-lying and submersible areas, high and higher and 90 degrees angle turnings, oil and gas storage areas also. Detailed profile should be from the details of route survey, route plan and profile is prepared. Profile is also termed as longitudinal profile or route profile. The profile is prepared and plotted paper rolls of graphed tracing paper. The profile shall progress from left to right. A typical profile is enclosed. Here we go. This is an example of paper representation of the transmission line installation. Detailed route profile should be graphical representation, preferably be on the scale x-axis 1 cm equal to 20 meter, y-axis 1 cm equal to 2 meter. As we study about the graphical representations, the plot plan of alignment of line from AP and to AP, plot distances, plot levels with respect to distance. All the villages lines are mentioned on the graphical representations. Let us start with tower spotting. Identify the position of the terminal tower. Start from terminal tower. Match the power footing curve with the position of terminal tower. Adjust the position of template. Ensure ground clearance. Identify the position of next tower and move the template to the next tower. Repeat the same procedure for next tower. There are some points for tower spotting. The first one is normal span. It is the design span, not the actual. Means at the time of designing, you mention the span between tower 1 and tower 2. The actual span, it means it is the actual distance between two adjacent towers. Actually, the distance covered between two towers. The next is null point. It is a point in a span where the position of the conductor is lowest. It is a point in a span where the sag is maximum. Means in between two, the center point is called null point. Means where the sag due to weight of the conductor is maximum. The next is weight span. The distance between two adjacent null points. Means the null point created between tower 1 and tower 2. It means the center of the two towers, and the third and the tower distance between the center point between tower 2 and tower 3. Two adjacent null points. The distance between two adjacent null points which the tower have to carry. And the last is wind span. It is the distance between two center points of adjacent spans. Means the center point of both the adjacent spans. This is the graphical representation for normal span, actual span, and the null points. And this is the limitations of span, profile span limitations. During the normal span, if we erect the line 110 kV or 132 kV, the normal span should be 132 meter length. And for 220 kV, the normal span length is 350 meter. And for 400 kV, the normal span length is 400 meter. Wind span. Wind span according to the chart for both end conductors or single line conductors. For both conductors, the normal wind span length for 110 kV or 132 kV line is 320 meter. For 220 kV line is 350 meter, and for 400 kV line is 400 meter. And if we use the single side of the tower, then the span length for wind span is for 110 or 132 kV line is 192 meter. For 220 kV line is 210 meter, or for 400 kV line, if we use the single side of the tower is 240 meter. The length is reduced as per if we use the single side of the tower. According to this, the weight span for double line or both hand used for 110 kV line or 132 kV line, the span length is 400 meter, weight span length 450 meter for 220 kV line and 600 to 800 meter for 400 kV line if we use the both ends of the tower. And for single side of the tower, the weight span length reduced according to voltage. For 110 or 132 kV line, the weight span length becomes 220 meter and 270 meter for 220 kV line and 300 to 400 meters weight span for 400 kV lines. And these are the file clearance for transmission line. Ground clearance. The minimum required ground clearance according to electricity board rules for 110 to 132 kV lines, the ground clearance required is 6.1 meter. For 220 kV line, 8.5 meter, and for 400 kV lines, 9 meter ground clearance is required. The clearance from other lines, LT to 132 kV, and from PNT lines, telecommunication lines. If we want to erect the 110 kV or 132 kV line, the minimum clearance from LT to 132 kV lines or PNT lines is 3.1 meter, and for 220 kV line 4.6 meter, and for 400 kV line the clearance increased up to 5.5 meter, the minimum clearance from these lines. And also for 220 kV line, if we want to erect the 110 kV or 132 kV line, the minimum clearance required is 4.6 meter. And if we want to erect 220 kV line, and here another 220 kV line passes through nearby, the clearance required is 4.6 meter. And for 400 kV erections, 5.5 meter clearance is required from 220 kV to 400 kV lines between. And same also for 400 kV line clearance, 110, if we want to erect 110 or 132 kV line, the minimum clearance required is 5.5 meter. And for 220 kV line, 5.5 meter from 400 kV lines. And for 400 kV lines, if two 400 kV lines passing through nearby area, then the 5.5 meter is the minimum clearance required for the new 400 kV line erections. And these are some clearance from the highway crossings, railway crossing span or distance between tower and railway track for different lines according to chart. 110 kV or 132 kV, if you want to erect, then the highway crossing minimum clearance required is 9 meter. For 220 kV line, highway clearance required is 9 meter, and for 400 kV lines, it is also the 9 meter from highway crossings. For railway crossings, 110 kV and 132 kV lines, minimum clearance required is 14.6 meter. And for 220 kV railway crossing line, clearance required is 15.4 meter. According means if the voltage increase, the clearance between the railway crossings, highway crossings and another line clearance also increased. The clearance for 400 kV lines from The railway crossing required is 17.9 meter. And the next is schedule for transmission line tower scheduled. Schedule where we start and up to the end of the transmission. How much angle of deviation from tower 1 to tower last and the span clearance, the side which we used for tower 1, left side or right side, the weight of the span from left side of single side tower or double side of or both end of the tower is used. These are the planned schedule as per actual. The next is check survey, marking of tower locations, forward and backward line points, pit marking and excavation. The next is transmission line foundation. We will start it in next lecture. For today, we will done for today. Okay, thank you. If you have any query or questions about this lecture, you may free to ask. Okay, thank you.